Hello and welcome to the 12th week of the problem solving session for this course. This will be the last week that we'll be discussing problems based on the assignments. Hopefully we'll be having one more session that will be dealing with some revision questions or the summary of all the weeks together. So in today's class, we'll be dealing with some sample problems that will help you solve the assignment 12 questions, as well as we'll be revising some problems and topics from week 1, 2, 3, and 4. And as usual, during these sessions, you're expected to, I'll be showing some of the questions on the display, and you're expected to put in your answers in the chat box so that we can make this an interactive session and discuss the solutions after I get your response. So let's start with the session for today. Hello. 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 Okay. So let's move on to the question discussion. And this week we'll be covering the final week's lecture that deals with the impact of climate change on the water resources. So the first question of the session is, which one of the following causes global warming? Please type in your answers in the chat box and then we'll move on for the discussion. Which one of the following causes global warming? Is it carbon dioxide, oxygen, nitrogen, or hydrogen? Okay, let's move on to the answer. So let's see what global warming is first. We'll see what global warming is first, and then we'll move on to what is causing global warming. So global warming is the gradual increase in the temperature of the earth because of the greenhouse effect. Now, global warming is a serious problem because the average temperature of the earth, which is supposed to be at an optimal level, it is keeping on increasing. And this increases as a result of the greenhouse effect. So what is the greenhouse effect? The greenhouse effect is the process in which the heat within the Earth's atmosphere is trapped by certain gases like carbon dioxide, water vapor, chlorofluorocarbons, and other pollutants, which results in the trapping the heat around the Earth's surface. Now, this greenhouse effect is a very uh, natural process. Although it is a very natural process, the problem is when the amount of these gases which are trapping the heat energy increases, a lot of heat is trapped, and as a result of this, the temperature keeps on increasing. So this is why this is what is causing the global warming. Now, global warming we saw is caused by greenhouse effect when excessive amount of the greenhouse gases are resulting in this increase in temperature. And some of the very common greenhouse gases are carbon dioxide, water vapor, methane, nitrous oxide, and chlorofluorocarbons. So this question here is about you can see here the greenhouse effect. Basically, the sun's light that is coming directly onto passing through the Earth's atmosphere, falling on the Earth's surface, is reflected back. When this light which is reflected back is what is being captured by the greenhouse gases, and when the amount of greenhouse gases increases, the amount of heat energy will also be um, will also increase. Now, carbon dioxide is one of the most common greenhouse gas. After that, there are fluorinated gases. Fluorinated gases examples are hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Apart from that, water vapor, methane, and nitrous oxides are also examples of greenhouse gases. So the answer for this question is, which one of the following causes global warming? It is carbon dioxide. Option A will be the right answer. Now, the second question, which one of the following results takes place due to global warming? We checked what global warming is. We know what is the basis or why global warming is caused. Now, what happens when global warming takes place? What are the consequences of global warming is the question here. Is it going to maintain steady temperature? Is it going to change, bring about changes in the rainfall? Is it going to give us a pleasant environment, or is it resulting in less pollution? Which one of the following results takes place due to global warming is the question. Okay. So the increase, basically global warming is the gradual increase in the temperature of the earth. Now, what all consequences are there, or what are the effects of these of global warming on various environmental factors is what is asked here. So we see that global warming is generally the increase in the earth, the temperature of the earth. Now, when temperature of the earth is increased, temperature of the air around the earth's surface increases. This will also result in increase in the temperature of water. The water body's temperature will increase. This is also resulting in rainfall. Uh, the change in location of the rainfall, change in intensity of the rainfall, change in duration of the rainfall, and also in the amount of rainfall. Not only that, some processes like high storm intensity, sea level rise, and the chemical and physical properties of oceans and coastal regions also happen as as a result of global warming as a climate change. So the question here is, which one of the following is taking place as a result of global warming? The correct answer is option B. Changes in rainfall occur. Steady temperature is not maintained. Temperature keeps on increasing gradually. The environmental pleasantness of the environment reduces as a result of increase in temperature and as a result of varying climate patterns. Then also pollution, the probability of pollution is one of the reasons why global warming is occurring. So the last option is also valid. So here the correct answer is changes in rainfall will. Moving on to the third question. Which one of the following is the effect of global warming on water resources? So we just went broadly through some consequences of global warming and climate change. Uh, One is the change in rainfall and some others. So which out of this is an effect on the water resources is the question. Okay. So let's see what all elements of the environment are affected by global warming and what are the impact of these changes on water resources. So, like I said, global warming is global warming, and we attribute this term global warming in relation to climate change. So, this climate change is generally increase in temperature. So increase in temperature is going to result in the increase in air and water temperature. Now, how does this air and water temperature increase impact water resources? As the temperature of water increases, this is going to result in so many changes in the aquatic ecosystems like the depletion of coral reefs. The temperature increase of waters in the ocean will result in processes like coral bleaching, which is going to deteriorate and make the corals dead. Now, removal of coral reefs is or the death of these coral reefs are going to result in a lot of algal formations, increase in algae. Increase in algae is in one way going to increase pollution. It is going to destroy the habitat of aquatic animals. So these are all the impact of air and water temperature increase on water resources. It is also going to reduce the quality of water, and so air and water temperature increase effect of water resources is happens this way. Now we also discussed about how it is going to impact precipitation. So as the temperature increases, what happens is the rate of evaporation also increases. So increase in temperature is going to result in more of the water getting evaporated. When more water get evaporated, there's all this evaporated water which is going to condense and stain, condense and form clouds are going to have to fall down as rain. So this increased rate of evaporation, increased moisture content is going to bring about precipitations which in a very erratic manner. So what happens is intensity of rainfall increases, where the rainfall should have occurred in a span of 10 or 20 days. The same amount of rainfall will occur in just 5 days, and as a result of this, the distribution, the temporal distribution of rainfall becomes less. That is, at a small time, a huge rainfall occurs. So because of this, what are the impacts? Water that is supposed to be absorbed by the soil will not be able to absorb this water. Instead, all the water will run off. And when runoff occurs, all this water which is supposed to go into the soil is going to going to join the oceans and the seas. Now, not only that, not just the amount of rainfall, the spatial distribution. That suppose the rainwater that is supposed to occur at a particular location, the location of rainfall is also going to change, and this is in totally bringing about a variation in the seasonal pattern of rainfall. Now, how is this going to impact water resources? Again, the availability of water and the quality of water. How is water availability impacted is through these processes. For a place which is getting high intensity of rainfall, that is a lot of rainfall in a small duration of time, the water will all flow off uh, into the surface rivers and streams. So the groundwater availability is going to reduce at that place. Now, in places where there is no rainfall because of the changes in rainfall pattern, when places don't receive any rainfall, then again the surface water availability, groundwater availability is going to reduce. So this is how the water availability is impacted. Now, water quality is also impacted. Like I said, when runoff is occurring at a very faster rate than it is supposed to, it is going to wash off all the pollutants and contaminants from the surface, particularly from agricultural areas. Whatever fertilizers are there will be carried away by this increased runoff, and this is going to join the rivers and streams and oceans and deteriorate its quality. And not only that, this wash off of contaminants into water bodies is going to result in a lot of algal growth and eutrophication, which is again impacting the quality of water. Another problem is soil erosion as a result of runoff. Then there is sedimentation processes as a result of runoff. So all of these are going to impact the quality of water also. So pollution, soil erosion, sedimentation, and then again flooding is a problem. So as a result of flooding, there are chances in urban places where the stormwater drains and the sewage drains, water gets mixed in. This is also going to result in polluting the areas. So this is the impact of changes in the precipitation pattern on water resources. Now, water is the climate change, global warming is going to increase the storm intensity also, because the sea surface temperature and the frequency of tropical storms is directly related, and it has got almost an exponential relation with the temperature. So as the sea surface temperature increases, the frequency of occurrence of this tropical storms also increases. Again, what will be the impact of this increased storm intensities on water resources is again similar to the problems of precipitation. The increased flooding is there. Then infrastructures which have been designed for a particular condition, they are not able to resist the storm intensity, the water accumulating as a result of floods resulting from these storm events. So that is going to be an issue. The damages to infrastructures, contamination, erosion, all of these are also consequences of increase in storm intensity. So that is the impact of storm intensity on water resources, increase in storm intensity on water resources. Then another very serious issue is the sea level rise. Now, because of this increased temperatures, the mountain glaciers and polar ice caps are going to melt. And as a result of this, the level of water in the sea is going to increase. Now, increase in the level of water of the sea is going to bring low-lying areas under the sea. So this is resulting in the damage to the lives in the coastal areas. That includes everyone, the plants, animals, humans, everything. Not only that, when we talk about the impact in water resources, the level of increase in the sea level, sea water is going to cause coastal erosion. It is going to bring on. I mean, it is going to almost drown off all the wetlands, mangrove areas, deltas, then salt deposits and salt water intrusion. Now, when this water level increases, the salt water is going to encroach into these lands. Not only lands, but it is also going to enter into groundwater and deteriorate the quality of groundwater. So this is the impact of rising sea level on water resources. Then changes in ocean and coastal areas. So these changes in ocean waters as a result of increase in temperature. Now, one of the major reasons why temperature is increasing is because of the carbon dioxide content that is increasing, which is a greenhouse gas and which is trapping the heat within the within the Earth's atmosphere. Now, this carbon dioxide will mix with the ocean water and form carbonic acid, which the process which is called as ocean acidification. Now, the ocean's water is as acidification of ocean's water is again going to impact the aquatic life and quality of water. So this is another, and also it is going to bring about a change in the physical and chemical content of the soil in the coastal areas, the water, the bottom of the, the content of the water and everything. So this is also a major impact of global warming. So this is what we were talking about, ocean acidification, where oceans are going to absorb carbon dioxide from carbonic acid, basic process which is called ocean acidification. This is going to impact marine organisms, calcify phytoplanktons. Then a major effect is on the coral reefs. The coral reefs starts to get extinct, and it has almost reached a state where coral reefs are diminishing at a very fast rate. And coral reefs are habitat to a lot of marine organisms, so that is also impacting a lot of marine organisms, the deterioration of coral reefs. So the effect of global warming, which out of the following is the effect of global warming on water resource was the question. And the correct answer is ocean acidification, option C. So the next question is the weather same as climate? The weather is same as climate. Is the statement true or false? We interchangeably use these terms, weather and climate. So is weather and climate the same term is the question. Okay. So basically, weather is nothing but it is the daily or weekly or monthly or annual short periods values of the parameters like temperature or humidity or precipitation or wind speed when we are taking a short period of all these values, then that is called weather. Whereas climate is this weather which is considered at daily levels or hourly levels or monthly levels or yearly levels. When they're averaged, all of this data is averaged for a span of say 30 years or something, then we say that is climate. So when we say climate change, a climate change is not as a result of 1 year or 2 years change in the weather condition, but it is the gradual change in weather over an extended period of time. So this is the basic difference between weather and climate. Weather is when we consider it for short periods of time, like you can say today's weather, the daily weather or weekly weather or monthly weather data. Whenever we collect data, it's always for the maximum data is for annual data. So if we get like 30 years of data and we average it, we can say that the climate, this is the variation in climate and aggregation of an extended period of weather for an extended period. So the statement is false. Weather is not the same as climate. The next question, what is the greenhouse effect? We discussed enough about what is global warming, what is causing global warming, what are greenhouse gases and greenhouse effect as well. So which out of the following is the greenhouse effect? Is it the decrease in the surface temperature, rise in the surface temperature, oxygen shortage, or none of this? Okay. So we studied about what the greenhouse effect is. It is when greenhouse gases like carbon dioxide, methane, they trap the heat within the earth and its atmosphere, and this is resulting in an increase in the temperature of the earth. So greenhouse effect is a rise in the surface temperature on Earth. Correct answer is option B. Moving on. In arid and semi-arid areas, the dependency on groundwater for water supply is between what percentage? What is the dependency on groundwater as a source of water supply in arid and semi-arid areas? So we know what arid areas is. We know what semi-arid areas is. You can think about the precipitation patterns in such areas, and then think about what is actually a major source of water supply for such areas. Okay. So arid regions, by definition, they are the regions which receive very less rainfall. Say around 25 centimeters of rainfall approximately is the amount of rainfall they receive. And semi-arid areas gets a little more amount of rainfall, something ranging from 25 to 50 centimeters of rain per year. So, so in such areas which is getting less rainfall, obviously the surface water as a source of water will be less, options will be less, so they have to depend more on groundwater. So in arid and semi-arid areas, the usage of groundwater extends from 60 to 100%. You can see here the dependency on groundwater for water supplies between 60 to 100%. Now groundwater, this is talking about groundwater as a resource for human development. Groundwater, it is not only used as a resource for resource for domestic requirement, but it is also playing a huge role as a source of water supply for irrigation in the agricultural sector. And it is said that 40% of the world's food is produced, world's food that is being produced is as a result of groundwater irrigated farming. even in low as well as high income countries. And yes, so in arid and semi-arid areas, 60 to 100% of the water supply is provided by groundwater. So the answer for this question would be arid and option D, 60 to 100%. Okay, moving on. The concentration of carbon dioxide in the atmosphere has increased from a pre-industrial value of about what? So, the concentration, we talk about climate change in terms of industrial and pre-industrial era. So, industrial era is the time after the industrial revolution when we started using the fossil fuels and all for various activities, and a huge increase in factories and industries and manufacturing units. Pre-industrial era is before this industrial revolution. So what is the concentration of carbon dioxide before, and to what extent has it increased is the question. Okay. So, like I said, the carbon dioxide concentration has increased from pre-industrial value. In the pre-industrial value, it was 280 parts per million. Parts per million is the measurement unit for carbon dioxide concentration. 1 parts per million is equal to 1 milligram per liter. So, before the industrial revolution, the carbon dioxide concentration had reached up to a level of only 280 ppm, while by 2005 it reached up to 379 ppm, and at present in 2023 the concentration of carbon dioxide has increased to roughly about 416 to 418 parts per million. And this why the pre-industrial and industrial revolution is important is because in the pre-industrial time the concentration of carbon dioxide resulted as increase due to natural processes, like the climate change was as a result of natural factors like change in the rotation pattern of the earth, change in the energy provided by the sun, and natural process. Whereas after the industrial revolution, there has been a huge input by human activities into the change in bringing about change in climate, particularly increasing concentration of carbon dioxide because of various industrial activities, combustion activities. So here the answer is 280 to 379 ppm. Option C. Concentration of carbon dioxide in the pre-industrial era was 280, which extended to 379 in 2005, and is something around 416 to 418 ppm right now. Moving on. The methane gas, how many more times is the methane gas more potent than carbon dioxide? Is the question. Methane is dash times more potent a greenhouse gas than carbon dioxide. Okay. So it's a 2 times more, 4, 15, and 21 or 30 times more. So let's see what potency is means actually. So when they say that a particular gas is this many times more potent than carbon dioxide, means they're comparing the equivalency with carbon dioxide. So if you take 1 ton of methane, then it is equal to some 21 times of carbon dioxide. So 1 ton of all these gases is equivalent to so many more times tons that of carbon dioxide. So if you see here, there are fluorinated gases. Earlier, there were chlorofluorocarbons, hydrochlorofluorocarbons, and halogens, which are released from air conditioners and refrigerants as an exhaust gas, and these were resulting in ozone depletion. And this substance was replaced by fluorinated gases, which is also a very powerful greenhouse gas. And it is said that fluorinated gases like hydrofluorocarbons, they are 140 to 11,700 times more potent than carbon dioxide. It means 1 ton of HFC is equal to 11,700 times carbon dioxide. The 11,700 tons of carbon dioxide. So, if 1 ton of this gas is emitted into the atmosphere, its impact is as strong as 11,700 tons of carbon dioxide. So, that is what is potency mean in this context. So, it is said that HFC is 140 to 11,700 times more potent than carbon dioxide, and stays in the atmosphere for up to 260 years, 1 to 260 years. Then we have PFCs. This is hydrofluorocarbons. Perfluorocarbons, which are 6,500 to 9,200 times more potent than carbon dioxide, and they also have a lifespan of around several thousand years. Similarly, SF6, which is sulfur hexafluoride, it is 23,900 times more potent than carbon dioxide. Also, very long lifespan. Methane has got a potency of 21 times more than carbon dioxide. N2O, nitrous oxide, has got 310 times more potent as carbon dioxide, and it has got a lifespan of 120 years. So these are how harmful, or these are the impact of these gases. Say if you release 1 ton of nitrous oxide, it is equal to releasing 300 times carbon dioxide, tons of carbon dioxide. So the correct answer in this for this question is methane is option C, 21 times more potent than greenhouse gas of the carbon dioxide as greenhouse gas. Okay, moving on. Which of these greenhouse gases is most abundant in the atmosphere? We talked about how harmful these greenhouse gases are in extent of how much more potent they are when compared to carbon dioxide. Which out of these greenhouse gases mostly the most abundant in atmosphere? Okay. So water vapor is also a greenhouse gas. It is also having the capability of trapping heat in the above the Earth's surface. So water vapor is the most abundant greenhouse gas that is available in the atmosphere. Not that it is harmful, but anything that is more than the optimal quantity or threshold value is harmful to the and is resulting in global warming. Now, the following percentage of value of irrigated produce in India is coming from groundwater irrigation. we have discussed about how much water is used in arid and semi-arid regions for as a source of water supply. Now, how much percentage of value of irrigated produce is resulting as a result of is resulting from groundwater irrigation? So, if you're having some irrigated produce and that irrigated produce is having say some value, then what value percentage of value is contributed as a result of groundwater irrigation? Is the question. Yeah. So 80 domestic groundwater is providing for around 80% of the rural domestic needs, and for urban areas it is contributing around 50% of the domestic needs are contributed by groundwater. And besides domestic purposes, around 50% of all the irrigated agriculture. Now the total 100% of agriculture happening, 50% is contributed by groundwater. So we know domestic needs in rural areas is fulfilled. Around 80% of the rural needs are fulfilled by groundwater. 50% in urban areas is fulfilled by groundwater. 50% of agriculture is occurring as a result of groundwater. Not only that, 70 to 80% of the value of the produce we are getting. That we get some irrigated produce, and out of that, 70 to 80% of the value is obtained from produce that is generated by groundwater irrigation. Not only that, that out of the total agricultural output, around 2/5 of the output is obtained from areas irrigated by groundwater. And groundwater is contributing groundwater in all forms as a source of water, as an income sources is contributing to 9% of the GDP. So here the question was, what percentage of the value of irrigated produce is coming from groundwater irrigation? It is 70 to 80%. So the correct answer for this question would be 70 to 80%, option D. Moving on, the projected climate change for the winter precipitation dash during the December-February period, which is implying greater water stress. So what is happening to the winter precipitation in December-February period that is resulting in greater water stress? Is it increasing, decreasing, or is it remaining the same, or none clear? Okay. So what is projected climate change? Based on whatever data we have now, and based on the historical data, there are various models which we have developed that are predicting what will be the condition of the weather and climate in the future. So projected climate change is nothing but what is going to be the climate change scenario in the future is what is called projected climate change. And as per projected climate change, it is said that in the uh, precipitation, that is winter precipitation, that they're obtaining during December, February time, it is going to drastically reduce, as a result of which it is going to bring about situations of water stress. So in the future, even now we have seen a very different pattern of rainfall occurring in various parts of the countries, that is resulting in extreme rainfalls in some places, resulting in flooding, and extreme reduction in rainfall resulting in drought condition. So again, this is going to worsen in the future. In the coming centuries, the precipitation is going to reduce because of the December, particularly during the December February period, and this is going to bring about situations of water stress. So correct answer option for this question is option B, decreases. The projected climate change for winter precipitation occurring during December February period is going to reduce, which is going to bring about greater water stress. Moving on to the next question. What can result in reduced groundwater recharge potential? Set intense rain occurring over a few days, less rain occurring over few days, precipitation occurring over an extended period, or none of the above. Okay. So what can result in groundwater reduction in the groundwater recharge potential? So what happens when intense rainfall is occurring over few days? Say like for 10 or 12, the rainfall that is supposed to be occurring for a span of 20 days. Suppose it occurs within the whole of the rainfall is occurring within a few days, then what happens is whatever rain that is falling on the earth's surface is not going to infiltrate into the soil. As a result of it, it is going to um, move into the ocean, seas, and rivers and all as runoff. So this is in turn reducing the groundwater recharge potential in that particular area where extreme or intense rainfall intensity is increasing. So groundwater recharge potential is reduced as a result of intense rainfall that occurs over a few days. If this rainfall is uniformly distributed or distributed for several days, then only, so if 5 centimeters of rainfall is occurring in 5 days and 5 centimeters of rainfall is occurring for a span of 20 days, then most of the water that is falling down as rainfall will enter into the soil subsurface in the form of infiltration. So here the answer is option A. Intense rain occurring over a few days is resulting in reduced groundwater recharge potential. This is also one of the serious consequences of climate change. Groundwater depletion. Groundwater resources will not be recharged in an appropriate manner, as a result of which it is going to bring about groundwater stress also. Okay, which out of the following are projected climate change impacts on water resources in India for the next century? So in the coming century, what are all the projected climate change impacts that India will have to face as a result of global warming and changes in precipitation? Will it increase the potential evaporation, result in sea level rise, or there's no change in winter runoff? Result all of the above. What are the projected climate change scenarios for future for the next century in India? So over the next century in India, India is going to experience sea level rise along the Indian coastline, not only in Orissa and West Bengal, but also along the majority of the Indian coastlines. There won't be any much change in winter runoff. Again, this is because the water precipitation is going to be very much reduced during the winter period. Although annual rainfall in the central plains are going to increase, evaporation is going to increase. Potential evaporation across India is going to increase as a result of increase in temperature. The rate of evaporation is also going to increase. So these are some of the problems our country is going to face as a result of climate change in the coming century. So the correct answer for this is all of the above. There is not much change going to be there in the winter runoff. 1 meter sea level rise is going to occur in Indian coastline. You have to imagine what 1 meter increase in water level means. It is going to be a huge increase. And the potential evaporation is also going to increase. So that was for about this week's session, 12th week's session. Now we'll be going through some questions as well as some key points that you will need. You can focus on for your revision for the upcoming exams. So let's move on to it. So let's move on to first the week one's revision. So here the question, what is the average annual per capita water availability in India in the year 2031? So the first series of lecture is covering, talking about per capita water availability, about the Ministry of Housing and Urban Affairs, about Jal Jeevan Shakti, the Ministry of Water Resources, which is Jal Jeevan Shakti. What are their guidelines, what are their benchmarks, recommendations, a lot of schemes under them, and what is the per capita water availability for various years. So here this question, average annual per capita water availability in India in the year 2031. The correct answer is C, 1367 cubic meters. So you might want to focus on this portion, which is giving us the average annual per capita water availability. For 2001 was 1816 cubic meters. For 2011 it was 1545 cubic meters. So this value is for 2001. This value was for 2011. 1367 1367 is the per capita water availability for 2031, and 1486 is for 2021. So these are the per capita water availability estimated for various years: 2001, 2011, 2021, 2031. And this is given by the Ministry of Jal Shakti. Then Ministry of Housing and Urban Affairs, they have suggested that 135 liters per capita per day should be as the demand for urban areas. So whenever we are calculating the distribution networks and all, we will be considering 135 liters per head for a day. And when it comes to rural areas, 55 liters per capita per day is fixed by the Jal Jeevan Mission under the Ministry of Jal Shakti. Ministry of Housing and Urban Affairs. So this is one part which you might need to focus on in the week one's portions. Again, this question is talking about the benchmark for urban water supply in India, according to the Ministry of Housing and Urban Affairs. Is it 150 urban water supply? So is it 55, 100, 180 or 135 liters per capita per day? It is 55 liters per capita per day for rural areas and 135 for urban areas. Again, based on the discussion points over here. Then you might want to focus on what a hydrological cycle or the water cycle is. What are the various components of a hydrological cycle? There is transportation component as well as storage component. Transportation components are all these components which keeps flowing, like the precipitation, infiltration, runoff, evaporation. All of these are moving, so it's transportation component. Storage components are groundwater, depression storage, surface water storage. All these are storage components of hydrological cycle. So you might want to focus on what hydrological cycles and all the points related to that, and what are the two different phases in hydrological cycle. It is the atmospheric phase and the terrestrial phase. The atmospheric phase is including liquid and solid as well as vapor. Liquid and solid is a liquid form of a form of water is rain, and solid form is snow. And in the vapor phase, we have the water vapor. Atmospheric phase is whatever water movement is occurring in the atmosphere. Terrestrial phase is whatever is occurring on the land and within the subsurface. So on the surface, we have runoff, which is a transportation component, stream flow, which is a component. Then in subsurface flows, there is infiltration, percolation, groundwater. All of these are coming beneath the surface. So these are subsurface components of the hydrological cycle. Some other points which you can keep in mind is what is surface runoff, what is surface detention, what is depression storage, what is infiltration, percolation. You might want to learn the definitions of all these and what they are. Understand what they are. Then again, what happens when the rate of rainfall exceeds the rate of infiltration? Now, if the soil can infiltrate, or the rate with which water is entering the soil is 5 centimeter per hour, and if the rate with this rain is occurring is at 8 centimeter per hour, then only 5 centimeters of water will enter per hour. The remaining 3 centimeters are going to go as runoff. So when the rate of rainfall exceeds the rate of infiltration, then the excess water that is accumulating on the surface will go off as surface runoff. In the other case, if the rate of rainfall is less than the rate of infiltration, then all of the water that is falling on the surface will go down as infiltrated water. So you might want to focus on the relation between the rate of rainfall, intensity of rainfall, and infiltration rate. You would also want to understand about terms called rate of infiltration, infiltration capacity, and all that, which is also coming in the later on weeks. But again, this is something that you have to learn. Then what is the percentage of water that is used for irrigation out of the total water used in 2025 for a high demand scenario according to NCI WRD report? This question was a general question, and this is the data relating to that. You can get information on this by going to this link. And here for irrigation, in the year 2025, around 72% was of the total water use was used up by irrigation. Then you might want to focus on the water budget equation. Water budget equation is nothing but the inflow components minus the total outflow is equal to change in storage. Inflow component over here is precipitation. Everything else is the outflow component. Surface runoff, water is moving on, going out. Groundwater flow also, water is going into the groundwater. Evaporation also, transpiration also. So the net change difference of the inflow rate minus outflow rate is what is staying back as storage. So that is what is given by the water budget equation. Now it can be written in two ways in this form as the sum of the components and as well as net inflow rate I minus O is equal to delta S can also be written. So this is one area that again you have to focus on. And then what are the sources of groundwater? There are infiltration galleries, infiltration wells, dug wells, tube wells. Yeah, these are the sources of groundwater, aquifers. Then there are sources of surface water, rivers, streams, lakes. What are the sources of surface water? The numericals based on water budget equation, something like these two types, where they're giving that the storage of water is this 17.5 hectare meter. They have given a time inflow outflow, so you will have to convert inflow and outflow into volume and then know what is the change in storage. So we have the initial storage. From these two components we can get the final storage. So what is the change in the storage can be understood from the water budget equation. So problems like this also is something that you might need to focus on. After that, uh, then you might need to focus on the distribution of global water. That is, we know that out of the total water, 2.5 percentage is fresh water, and in that 2.5 percentage, 30% is covered by groundwater, and the remaining by surface water and glaciers. In surface water itself, out of the 1.2 percentage, uh, lakes and atmosphere, rivers, and all, how much water is covered by these water bodies is something that again you might want to focus on in from the week one's lecture. So these are the major points you need to study. Major ones, it is expected that you go through all of the portions, but again, these are some of the areas majorly covered in this first week's lecture. Moving on to the second week. Second week is about what an aquifer, geological formation, what is an aquifer, what is an aquitard, what is an aquifluid, and what is an aquifuge. You have to be thorough about these formations. Aquifer is the geological formation that helps in transmitting as well as storing as well as transmitting water. And what is the example for aquifer? It is sand, gravel, etc. Aquitard, on the other hand, is a geological formation that can also store and transmit water, but then it is not very, the yield is not as significant as that of a aquifer. So examples of an aquitard is clay lenses bedded with sand. And in the week two's lecture, problem solving, I had also given a pictorial representation of what is clay lenses. So you can go back to that and check. Then aquifluid is a formation. It is an impermeable formation. It can store water, but we cannot obtain water from clay. I mean, these aquifluid geological formations called aquifluid, and example is clay. An aquifuge is one formation which cannot store neither transmit water. So you have to be thorough about all these geological formations. Then questions like what is an aquifer can come, or questions saying what is the formation which only seepage is possible. Yield is insignificant. What is it called? Is it an aquifer, aquitard, aquifluid, or aquifuge? Since all of these terms are very similar to sea, you have to be very careful about being very specific about what formation is what. Then also Another important area covered in this is what is confined and unconfined aquifer. Confined aquifers are aquifers that are confined by two impermeable layer on top and bottom, whereas unconfined aquifers are aquifers which only have an impermeable formation at the bottom. Top is free, so the water table is at an atmospheric pressure, whereas in confined aquifer, the water in confined aquifer is under certain amount of pressure. It is not under atmospheric pressure. It can increase or decrease pressure because the water movement is not possible vertically. I mean, the level of the water cannot increase because of this confinement. So a type of aquifer that has free water surface called as the water table is the unconfined aquifer. Similarly, they can ask questions on what is the aquifer that is confined by two impermeable layers, or in which the water is under pressure. All these questions will have the answer as confined aquifer. So this is another point that you might want to focus on in the second week's lecture. The other point is what is specific yield, what is specific retention, and what is porosity. Specific yield is the amount of water that is draining off an aquifer under the influence of gravity, computed per unit volume. And specific retention is the amount of water that is retained back in the aquifer after the water has drained out under the influence of gravity. Now, specific yield is given by the volume of the total volume of the dry matter divided by the volume of the water divided by the total volume, and here volume of the water retained by the total volume. The volume of the water drained by the total volume and volume of the water retained by the total volume, and sum of the specific yield and specific retention is equal to porosity. This relation is also very important. Based on this relation, we will be having numerical problems that will come. And also they can ask directly what is specific yield and give the definition here, or they can give the definition here and say which out of the following terms represent this definition. So you should be clear about the term and what is its definition, the mathematical representation, and this relation between specific yield, specific retention, and porosity. Then again, examples about all these formations. We had learned about the different types of rocks, that is igneous rocks, sedimentary rocks, and metamorphic rocks. So what are igneous rocks, what are sedimentary rocks, what are metamorphic rocks, and examples of these three types of rocks. And all these rocks under which type, whether it comes under aquifer or acutard or aquifuge. We have learned about sedimentary rocks being aquifers. We had also seen questions where fractured limestone rocks are better aquifers than sandstones or sedimentary rocks. So you should also understand why, because fractures are able to transmit water in a better way in comparison to the pores. So all these geological formation, examples of geological formation, are these geological formations a good aquifer, or does it come under what kind of geological formation these rocks come under is also something that you might want to focus on in the week 2's session. Then what are consolidated, semi-consolidated, and unconsolidated rocks? So this is a portion which is saying that consolidated rocks are rocks which are cemented very hard together. And what are the examples? Then semi-consolidated is during this induration process or the hardening cementing process, it is incomplete. As a result of it, there are some pore spaces, whereas unconsolidated rocks are highly porous rock. So what are the examples of these three categories of rocks? Then what are perched aquifers, and what is this boundary that is separating unsaturated area and saturated area, which is the water table? All these points are the points of focus for the week 2's lecture. Here they're talking about consolidated, semi-consolidated, and unconsolidated formations. Moving on to the week 3's revision points. Week 3 is majorly dealing with the Vadose zone, and that is the unsaturated zone and the saturated zone. Unsaturated zone has got three classification: the soil water zone, intermediate zone, and the fringe water, the capillary fringe zone. So soil water zone is the it is a saturated zone in unsaturated zone. We call this the zone of aeration as also the unsaturated zone. But in that zone, the first layer of soil is saturated by the water that will infiltrate. Now, after it infiltrates the soil water zone, only it will start moving gradually down to the deeper layers. So that is called a saturated layer in the unsaturated zone. Now, intermediate zone is a zone which consists of soil as well as air particles. Capillary fringe is that zone where water from the water table moves up as a result of the capillary actions of through the series of pores. So, what are these three segregation of layers of the soil based on the pore spaces as well as the amount of water that is occupying the soil zones. And below the water table, that zone is called the zone of saturation. So this classification is something that is majorly focused on the third week. The zone and what all are the characteristics of the zones. The zone is holding water that is available to plant roots is called the soil moisture zone. Then zone responsible for filtering out the precipitated water is a Vadose zone. Then a zone that is extending from the top of the ground surface to the water table is the zone of aeration or unsaturated or the Vadose zone. So a zone of aeration is also called the Vadose zone. So this is one area of focus on the week 3's lecture. Then another focus area is the types of water. What is capillary water, gravitational water, hygroscopic water? So they will ask questions by giving the definition of the water. In this case, what is the term used to describe a thin layer of water that is adhered to soil particles that is unavailable for any use? It's a question. It is hygroscopic water. So hygroscopic water is the layer of the water that is adhered to particles and which is not available for any kind of use. It cannot be taken up by plants, or it cannot evaporate in the form of water vapor also. Capillary water is the water that is available in the capillary fringe, that is going as a result of capillary action. The water that flows through these interconnected pores from the water table is called capillary water. Gravitational water is the water that is getting, flowing down as a result of gravitational action. Then another area of focus and a very important area is the Darcy's equation, which is giving us the relation between the velocity of the water that is flowing through the soil particle and the hydraulic conductivity of the material and hydraulic gradient. Hydraulic conductivity is nothing but it is the coefficient that is representing the property called permeability of the aquifer material. Permeability is again that property which is giving us an idea about the ease with which water will flow through the aquifer. So Darcy's equation is given by V is equal to K into I, where K is the hydraulic conductivity, I is the hydraulic gradient. So we also learned about what hydraulic gradient is. It is the change in the pressure head by the total length through which the flow is occurring. So Darcy's equation, what is permeability, what is hydraulic conductivity, hydraulic gradient, and these numericals that is related to Darcy's equation is very important. This is a short question that can come. Then again, we learned about the velocity rate. Discharge rate also can be found out from Darcy's equation by substituting Q by A in V. and then interchanging the terms. So such questions can also come in terms of the Darcy's equation. So those are the important parts when it comes to week 3 lecture. In week 4 lecture, in week 4, the usage of groundwater, certain formulas for groundwater recharge. For example, such numericals will be given where precipitation is given. You have to find out the recharge. So the formulas like the Bhattacharya's equation, these are empirical formulas. So it is important that you learn the units also, which is units of the terms in this equation. So there is Bhattacharya formula, Krishna Rao's formula, Chaturvedi's formula, Segal's formula, Radhakrishna, Datta et al.'s formula. So these formulas are something that you might want to learn, because based on these formulas, there will be questions asking for to find out the groundwater recharge. The numericals like this can come. The other points are potentiometric surface and piezometric surface. We studied what is the potentiometric or piezometric surface. Say water in confined aquifer, it is having certain amount of pressure. So if it is allowed to, if a well is drilled into it, then what is the level of water that is coming is will give us an idea about the pressure head of the water inside that aquifer. So potential isometric surface is nothing but the surface or the imaginary line that is formed by water if number of wells were put in between, and the water connecting all the water levels of these potential wells. And also you have to be aware of what an artesian well is, what is flowing artesian wells, what different types of wells, dug wells, tube wells, uh, bore wells. Then what is the pressure of water in aquifers and confined aquifers. There is also another portion dealing with perennial streams, ephemeral streams, and intermittent streams. Perennial streams are those streams which are running, I mean, which has water all throughout the year. Ephemeral streams are streams that has got water only during very less periods. That is when rainfall occurs, it will be available for a very short period, less than say 30 days. Intermittent streams are in which water is available intermittently. Even during the precipitation events, water will start flowing. And even after the precipitation stops for somewhat for a little more duration, water is going to be available. So these are the different types of streams. Then what is an effluent and an influent stream? Effluent stream is when water is being water from the groundwater is going to go to the surface water bodies. That is, the groundwater is recharging surface water. An influent stream is when the stream is providing water to groundwater. So these are some important points that you might need to focus on the 4th week's lecture. So that was about the for today's session. We covered topics that are related to assignment 12, and also went through some focus areas that you will need to cover in the first 4 weeks lecture. So I'll be putting a loop of these slides now, and you can go through it and open to doubts if you have any. Otherwise, you're free to leave the session. That's all for today, this week's session. Probably there will be a summary session, which I'm not very sure of, but then if we can meet during the session, let's meet. Otherwise, all the best for your exams and do well. And yeah, have a great week. Thank you and bye bye.